Hello everyone and welcome back to another video. This one has been in the works for a very long time, but it has been absolutely worth it because today I'm going to answer a question that I should have asked a long time ago, and especially looking at what other tech YouTubers have said or published in the last couple of days, it is actually quite relevant. Because today I'm going to present a ton of testing data on how much extra performance overclocking actually gets you in the real world. We're not just going to look at one single overclock component in one single test, we're going to look at an entire system that has been overclocked in a whole suite of tests and real games, and we're going to look at the gains from 4 different performance levels. Everything at full default settings, everything at default but XMP enabled, an easy overclock, and a full overclock. So strap yourselves in, as today we are going to finally answer the question, is overclocking actually dead? Right after this special offer from PCBWay. PCBWay is celebrating their 10th anniversary with their badge design contest. Celebrating a decade of innovation with PCBWay and enabling you to win prizes by designing a badge celebrating PCBWay's achievements in the last 10 years and those still to come. They are offering free prototyping services for badges that meet their design requirements, as well as a $50 PCBWay coupon. And if they like your design, they will feature it on their channels, and it might even become their official 10th anniversary badge. Submissions are open until May 31st of 2024, and the winners will be announced in June. And as always, PCBWay is available for all your PCB prototyping and assembly needs. You can quickly go through their simple ordering process, receive a quote, and have your design be ready for shipping as fast as within 24 hours. PCBWay also offers flexible PCB options, SMD stencils, CNC machining, 3D printing, and injection molding. So whatever part you need, you will probably find an option at PCBWay to get it made professionally. I am very thankful for PCBWay's sponsorship, as it helps immensely with running the channel, and it is a service that I would actually use. So if any of this interests you, please go ahead and give PCBWay a try. So I put my test bench together with my Ryzen 7 5800X, my MSI B550 Unify-X, 2 8GB sticks of Samsung 8GB B-Die, and my GTX 1080 Ti. That kit has an XMP spec of 3200, 16, 18, 18, 38 at 1.35 volts, which is the most popular DDR4 XMP spec. 3600, 18, 22, 22, 42 is also somewhat popular, but 3200 is by far the most popular XMP spec, and because I do want this to be as representative of the real world as possible, I just chose what is the most popular. All of this hardware might be slightly dated, but if you look at how current generation hardware like Nvidia's 40 series and Ryzen 7000 CPUs overclock, it's essentially the same way, and the gains in percent are going to be very similar. There are going to be some differences if you have an AMD graphics card or an Intel CPU, but if you run a Ryzen CPU and an Nvidia graphics card, I expect that you will see essentially the exact same gains, even if your hardware might be 1 or 2 generations newer. I had originally also planned to use a copy of my daily system's operating system for testing, because that would be more representative of real-world performance. However, I had some big issues with compatibility issues. The hardware between my daily system and my test bench is fairly similar. They're both Ryzen 5000 CPUs, they both run 8GB B-Die from Samsung, and they both run Nvidia graphics cards, but there were issues, and the results I got were very obviously flawed. So I decided to go with a blank operating system instead and redo all the tests. I used this opportunity to also introduce an extra performance level to test. Originally, I had used a complete bone stock all default settings baseline, but I never actually had a test where I left everything stock but enabled XMP. Now, my original reason for that is that the vast majority of people either have RAM that doesn't support XMP or they buy pre-built PCs which often have it disabled by default. Therefore, the vast majority of people don't use XMP. However, I realize that, especially when it comes to the audience of my channel, most people watching this video will have XMP enabled. Therefore, my baseline was a bit unrealistic. In the end, I decided that both baselines have a reason to be in my testing, and I chose to go with both. So I have a baseline where everything is stock that I marked as JDAC, a baseline with XMP enabled, which I marked as just XMP, and then two different overclocking settings. The first one I call the easy overclock. That one still has XMP enabled, but also PBO for the CPU, and it has the graphics card overclocked in MSI Afterburner. This is an overclock that I expect people to be able to set up within an hour or so. It is fairly easy to set up, and therefore not a huge hurdle to do. The second overclock is the full overclock. In this one is quite a lot harder to set up. In addition to PBO, the curve optimizer is also enabled in BIOS. The graphics card is still overclocked with MSI Afterburner, but crucially the RAM is also manually tuned instead of using the XMP profile. That last part is the main reason why this takes so much longer to set up, and also the main reason why, in some cases, it is going to be quite a lot faster than the easy overclock. So with that out of the way, we could get started with the first batch of testing. Some good old simple synthetic benchmarks to start off with. First off, we have LinPack, one of my favorite tests, and here we can already see, yeah, there is quite a distance between the easy and the full overclock. In fact, the easy overclock is essentially the same as XMP, which already doesn't have that much of an advantage over the full bone stock everything default JDAC baseline. This was pretty much expected. I run LinPack a lot, and LinPack absolutely loves custom-tuned memory timings, so I'm not expected in seeing a huge gain here. However, not every single synthetic benchmark acts like LinPack. In Y-Cruncher 1 billion, this is a test where a lower number is better, we actually saw a decent difference with just XMP and the easy overclock, which are still fairly similar, but the custom overclock no longer has as much of a commanding lead over everything. It is a little bit more balanced out, with the JDAC profile being far behind the other three. In 3DMark Time Spy, we can see that both overclock levels are now fairly close to one another. The only real difference is in the CPU score, where the full overclock has quite the advantage. But in everything else, especially the GPU score, since the GPU settings between the two are identical, we have essentially the same performance. We can still see a pretty huge gain over just running the XMP, which again seems to be basically in line with just not running XMP, but the full overclock seems to not be as fast anymore compared to the easy one. In 3DMark Firestrike, we essentially see the same thing, except that the CPU score advantage is now essentially gone. The CPU scores are basically all within margin of error of each other, so the only real difference comes from the graphics card overclock, which again means that both our overclocks are fairly close to one another and a fair bit faster than JDAC and XMP. Lastly, Cinebench. This is R23. I tried to get R24 running, but for some reason it wouldn't launch, so I went with R23 instead. And, well, it's Cinebench. I was expecting this. There are no gains whatsoever. Perhaps the full overclock is a very slight bit faster, but really, this is all margin of error. Cinebench really only cares about the raw clock speed of your CPU cores in an all-core load scenario, something that PBO doesn't really change, so essentially the score stays the same no matter what you do to your PC. You can run everything at default or you can overclock everything, Cinebench doesn't care. We would have seen a score difference if I had gone for a static all-core overclock on the CPU, however that is not what most people do. This is something that would be worth it if you were mainly using your PC for video rendering, for example, but this is something that would actually take some performance away from you in daily tasks and games, and since that is what most people do with their PCs, I went with PBO for everything here. And that's why there's no difference. With that, our synthetic benchmarks would be through, and it is now time to look at all the games that I tested. Before we get into that, I need to do a little bit of explaining though. For the games, we have logged the average 1% low and 0.1% low FPS. I think that by far the most important metric here is the 1% low FPS. The average shows you a sort of ideal of what your game could be running. In an ideal scenario, your average 1% low and 0.1% low FPS would be exactly the same. However, a perfectly efficient PC doesn't exist, and there will always be a bottleneck. So your 1% low and 0.1% low FPS tend to be lower than your average. 1% low FPS give you a good idea of how smooth the game feels. If you've ever been in a situation where you have a game that is running at a very high FPS, but the game feels like it is running at a very low FPS, you probably had bad 1% lows. This is why I think this is so important. You can have extremely high average FPS, but if your 1% lows are bad, then the entire experience is going to be bad. 0.1% lows are a little bit different. They mostly show you how stuttery a game is, so when a big thing loads in and the game pauses for a little bit, that is going to be represented in 0.1% lows. Now, an overly stuttery game is still not a great thing, but I think that a game that just feels like it's running very, very slowly is worse than a game that just stutters every now and then. So, I think the 1% lows are the most important metric to look out for here. 0.1% for, how stuttery it is, and the average for a sort of ideal baseline. When it comes to the settings I ran these games at, I actually went and min-maxed, customized something that actually suits the system well. Because again, I wanted something that is as representative of the real world as possible. Therefore, I sought a compromise between having great quality and also still great FPS, sort of shooting for the point where I can still crank up the graphics without losing too many FPS, since that is what people would be doing in the real world. Overall, games ran from medium to high settings, and some games like Rainbow Six Siege, Overwatch 2 and Counter-Strike 2 just ran completely maxed out. What I'm trying to say is just I never had to lower the settings all the way to the bottom. I was running respectable settings that fit the system just fine. So with that out of the way, we can look at our very first game. That would be Rainbow Six Siege. And we can see a pretty interesting pattern here. We can see that, again, XMP and full JDEC are essentially identical, and we can see that both our overclocks are noticeably faster, especially in the 1% and 0.1% lows, where there's a much bigger difference than in the average. This is what I was talking about. Your average FPS look like they don't go up by a lot, but your 1% lows and 0.1% lows, they go up by quite a bit more. So your average FPS is not going to change much, but the game is going to feel a little bit smoother. If you had a 240Hz display, that would potentially be a noticeable difference, even though the average doesn't seem to indicate that there actually is a difference. Again, the easy and the full overclock are very close to one another. The full overclock is very slightly faster, but that is such a small difference, I don't think anybody would be noticing that. For the second game, we have Helldivers 2, and this is something interesting. The XMP is actually slower than leaving everything on auto. This is something that has been observed a couple of times because of how XMP works. It really only sets your frequency and your primary timings. Everything else is more or less left up to the motherboard. And some motherboards just take the JDEC timings and scale them to the frequency, which results in very, very loose subtimings. And if you have a game or an application that is very sensitive to memory timings, you can actually end up losing performance by using XMP. And it seems that Helldivers, with the exception of 0.1% lows, is such one case. So here we have a base JDEC that is actually faster than the XMP. It is almost catching up to the easy overclock. Only the full overclock can really pull ahead of everything else here. That is something to keep in mind. XMP is not an always better solution. It usually delivers better performance, but you can have cases like this where your performance actually gets worse. This is why I always recommend to at least set some of your subtimings up properly, particularly the TRRD timings and the T4 timing, because those are the worst examples of being scaled far too loosely when you use just XMP. Then we have Doom Eternal, which is mostly similar to how Siege went. We can see XMP and JDEC are again very close to one another, and both the overclocks are also very close to one another. 0.1% lows, there's a bit more of a difference with the easy overclock. It actually seems to be a little bit of a disadvantage. I don't think that's anything more than just margin of error. But yeah, our overclocks do deliver a noticeable difference here, although not a very massive one, but a noticeable one. Then we have Baldur's Gate 3, a game that came surprisingly close to running at ideal FPS, at least when using the overclocks. We can see the JDEC spec is quite far behind here, with XMP almost catching up to the easy overclock in 1% and 0.1% lows, and really only the full overclock again pulling ahead of the pack. Counter-Strike 2, this is an interesting case. As you can see, the 1% lows for the full overclock are absolutely massive. This looks like a data error, but it isn't. This actually runs like that. Counter-Strike 2, as it turns out, has extreme scaling with manually tuned RAM. So our full overclock managed to increase the 1% lows by a massive margin, where everything else improved just a slight little bit. So if someone was just testing with average FPS, they would be seeing, yeah, the full overclock is a little bit faster. But really only we can see just how much of a difference to the overall gaming experience the overclock makes because we're looking at the 1% lows. That is a massive difference. Horizon Zero Dawn is also a game that experienced some quite good scaling, something that I wasn't expecting. This is a single-player game that is mostly graphics focused, but we did see some decent scaling here. It did not stop scaling with the higher overclocks, something I didn't really expect to see, but it is welcome anyway, because that proves my point that overclocking is pretty much worth it always. Microsoft Flight Simulator is more of the same. We can see, yeah, JDEC and XMP are trading blows again, but the overclocks are pulling ahead, and considering that this game runs at pretty low FPS, that 10 FPS or so you get in addition is actually going to do quite a lot for your gaming experience. Overwatch 2 is a game that, like Counter-Strike 2 in the past, has shown some pretty massive gains with faster RAM, but here I'm not seeing that same massive jump as with Counter-Strike 2. Now, this time I was testing on Ryzen, and the last couple times I tested this game I was on Intel with a CPU that has less than half the cache of the Ryzen 7 5800X, which probably meant that the game scaled more with RAM because, well, the CPU just had less cache and was relying on it more. But we still saw some decent gains, and again we can see that the XMP is actually worse than JDEC in this game. Overwatch 2 seems to be equally as sensitive to memory timings as Helldivers 2, and with knowing that, it is probably worth to overclock in this game. If you're running XMP, there is a good chance you would actually be better off turning it off. And at the very last, we have Satisfactory. Now, this game has one tiny little actual data error, and that is the 0.1% lows for the easy overclock. This is not like it should be. I did rerun the game a couple of times, and the 0.1% lows were essentially random. From run to run, they would change massively, and I don't really know why. The average and 1% lows would remain mostly the same, but the 0.1% lows were fluctuating wildly. Ultimately, I decided to just not pay too much attention to the 0.1% lows in this game, because they tend to be so unreliable. But yeah, the easy overclock falling behind everything else here by so much that should not be happening. And I did mark this as unreliable data in the final results, so it is not going to impact our final conclusion. Speaking of final conclusion, here are two big tables that basically boils down all the data we just went through. Instead of just showing FPS and performance numbers, this represents the improvement in performance over our two baselines, the XMP and the JDEC spec. And as you can see, everything is color-coded to whether it would be a noticeable, non-noticeable, or very noticeable improvement. This is based on the fact that a difference of smaller than around 7% tends to not be noticeable by the human eye without actually measuring it. And an improvement more than 7% tends to be noticeable by a human being without measuring it. Then 15% is another barrier, because if you look back in time, 15% more performance tends to be around where a next generation piece of hardware tends to sit at. If you have a CPU and a new generation comes out and you buy that new generation CPU replacement for your current one, it tends to be about 15% faster. So if we got improvements here that are about 15%, you are essentially getting a CPU upgrade for free, or really any hardware component upgrade for free. And as you can see in the tables, there's a lot of green here, a lot of dark green too, actually. But let's go through it in a little bit more detail once again. Now, because this takes a lot of time, I'm only going to go through the XMP table in a lot of detail, but you can pause the video and look at the JDEC table if you want. I ultimately chose to go through the XMP table because it is more representative of what people in my audience would be running. But if you are one of those people who have RAM who don't have an XMP spec, or maybe you bought a pre-built PC and, as it usually happens, that pre-built PC came with its XMP disabled and you haven't enabled it yet, you can also look at the JDEC table for comparisons. But anyway, I put down the improvements in performance as a percentage number, like I said, and I also put two checks. If the 1% lows increased by more than 7%, I say the overclock is worth it. That is the bare minimum the overclock has to achieve. If the average and 0.1% lows also increase by more than 7%, then that is a nice bonus. But the main requirement I had here was that the 1% lows had to increase by 7% or more. Because again, the 1% lows show you how smooth your game really feels. The average is not always representative of how smooth your game is actually running. You can have a game running at 100 FPS and it could feel like it's running at 30 because your 1% lows are, well, 30. So yeah, Rainbow Six Siege did increase a decent amount. 9% for the easy overclock and 11% for the full overclock. The average didn't increase by that much, just 3%, which is essentially margin of error, but the 1% lows and 0.1% lows did. Therefore, both overclocks are worth it here. In Helldivers 2, we did see a decent bump to average FPS, however the easy overclock did not achieve the bare minimum 7% in 1% lows. The full overclock achieved 20.5%, which is a huge difference. The full overclock is definitely worth it here. However, the easy overclock is probably not going to really change your experience. It might even give you a false sense that it got better, since the averages are increasing by a noticeable amount, but your 1% lows stay more or less the same. So your number is going to be higher, but your game is going to basically feel the same. In Doom Eternal, we have again decent gains in 1% lows, clearing the 7% requirement, and therefore both overclocks are worth it. However, the easy overclock is fairly close to the 7%, and the 0.1% actually got slightly worse, whereas the full overclock got a decent bump, almost making it to 15%. So I would certainly recommend a full overclock for a game like Doom Eternal, even though the easy one would still get you a noticeable improvement. In Baldur's Gate 3, the easy overclock is not really that great once again. The averages are increasing, but the rest is not. So the easy overclock in a game like Baldur's Gate 3, not gonna impact your experience that much. The full overclock, however, that is a 2-digit improvement for everything, and that's definitely worth it. Counter-Strike 2, well, the easy overclock is, again, not that great in this game. Not a huge difference. It doesn't seem to really care about PBO being on or the graphics card being overclocked. But what it does seem to care about is properly set up RAM. Damn, 41% better 1% lows. That is insane. That is more than one generation. That is more than 2 generations of newer hardware worth. That is an insane improvement in how smooth the game feels. Even with the averages don't really change that much. People who just look at the average FPS, they're not gonna really notice that the game actually starts to run so much better. So yeah, full overclock, very worth it for Counter-Strike 2. Horizon Zero Dawn does clear the requirement for both overclocks, even though the easy overclock is just barely making it, with the full overclock getting a very respectable 18.8% better 1% lows. That is definitely worth it, and like I said, I wasn't expecting this game to really benefit from anything other than GPU overclocking, but as it turns out, RAM overclocking seems to do quite a lot more for this game than overclocking the graphics card. Microsoft Flight Sim, well, that is again a very respectable improvement for both overclocks actually, but the full overclock is just full clearing everything over 15% here. And yeah, I can definitely recommend overclocking for this game. It is very hard to run, and we can see that in the results. Overwatch 2, very similar, even more dark green. Both overclocks achieve almost universally more than 15% improvements, and the full overclock is also nearing 40% better 1% lows. Again, that is multiple newer hardware generations worth of improvements from just overclocking. Satisfactory. This game I thought would scale a lot, but as it turns out, it really doesn't change that much. Again, the 0.1% lows were fairly random, which is why one of them decreased by a lot and the other increased by a lot. I wouldn't pay too much attention to that, and yeah, I did not include these results in the final total improvement numbers. But yeah, this game I thought would like faster RAM and a faster CPU, but it did not. It really didn't change that much. So surprisingly, this game is not really worth overclocking for. And if we look back at our synthetic tests again, well, Linpack very much likes faster RAM, so of course the full overclock is worth it here. While Cruncher, yeah, it did see better improvements for the easy overclock, but not enough to reach 7%, so again, the full overclock is worth it here. And then for both of our 3D marks, we did see decent improvements, and now where we've gone through the games, there are some games that actually like overclocking a lot more than 3D Mark. We don't really ever reach dark green territory here, other than just barely with the CPU score and time spy, which is interesting because I always thought 3D Mark would be a sort of ideal estimate that would be optimistic for your gains. But as it turns out, actual real-world games, in cases such as Overwatch 2, Microsoft Flight Simulator, or Helldivers, they tend to improve more than these actual purpose-built benchmarks. Which is interesting because I always assumed that a benchmark would see every last bit of improvement better than a real-world workload. As it turns out, that's actually not the case. And very lastly, we have Cinebench. Oh, the meme that Cinebench is. Yeah, Cinebench did not care, as expected, and we should just get on with it. So, if you're still with me, we can now look at the total improvements. Where it says total improvement, that is all of the data averaged out, except for the 0.1% loss for Satisfactory. I marked those as erroneous, so those are not in there, but everything else is. And so, finally, at long last, we can say, if you do an easy overclock, you just turn on XMP, you set up your boosting algorithm for your CPU like PBO, and you spend a little bit of time overclocking your graphics card in Windows, you can expect 8.6% better performance. That is more than 7%, it's fairly close to 7%, but it is more than 7%. That is a noticeable improvement in performance, and therefore, I can say it is worth to overclock. Full stop. And things get quite a lot more interesting when we look at the full overclock, because this is almost 20%. Yeah. If you have the time and the willpower to spend a lot of time testing, setting up your curve optimizer, and specifically setting up your RAM and its subtimings properly, you stand to gain honestly insane performance improvements. Almost 20%. That is more than an entire generational jump. That is very noticeable. If someone you know buys a next generation chip and then doesn't overclock, you will still have better performance than that person with the newer hardware. That is quite insane. And this basically brings us to the conclusion of the video. No, overclocking is not dead. It is in fact more alive than ever. Performance improvements like this are noticeable, very noticeable for the full overclock. Current generation hardware, that's DDR4, DDR5, and also graphics cards with their memory systems, are very dependent on having data arrive quickly enough at the processing cores. We have so many processing cores now, and they're running so fast that you need to keep them fed with data. This is why faster RAM, both VRAM on your graphics card and system RAM for your CPU, is very important for performance. And we can see here, if you set it up correctly, you stand to gain a lot of performance. People who say overclocking is dead, people who say overclocking doesn't affect performance that much, they are simply doing it wrong. It is that simple. The data is right here, and it is very conclusive. And we can also look at the game improvements specifically if you want to say, but the synthetic benchmarks are in there and they're not representative of the real world. Well, let's look at the games. And this is interesting. The averages improve by a lot less than the 1% and 0.1% lows. This is interesting because usually when new hardware comes out or a lot of data is being tested, a lot of the time just the average FPS are being presented, because also testing 1% and 0.1% lows and presenting all of that in a video would be very time consuming and complicated. So usually people only test average FPS when a new piece of hardware comes out. And well, the improvements in average FPS, yeah, they still clear the 7%, but they are very close to that 7%. They are not anywhere close to matching a next generation piece of hardware. So if you overclock this, even if you went for the full overclock, in average FPS, a new piece of hardware would still win. However, if you look at the 1% lows and the 0.1% lows, that changes specifically for the full overclock, because those improve even more than our total average. So we take the synthetic benchmarks out and we get more improvement. Yeah, real-world games scale more than synthetic benchmarks. That is something I was not expecting to see here, but here we are. 21.7%. That is noticeable. That is very noticeable. I don't think we have hardware generations that improve by 21.7% that often. So, in terms of what actual gaming experience you get, and not just what arbitrary number you get on screen for your average, overclocking is better than buying a new piece of hardware still today. And all of this remains true if we look over to the other table that compares to JEDEC. Yeah, we had those few cases where the XMP was actually losing to JEDEC. Satisfactory is one of those cases. There it actually becomes worth to overclock if you run JEDEC. But the picture doesn't change. The total average is higher for the JEDEC baseline than the XMP, and everything I said is still true. Overclocking is not dead. Overclocking just needs to be done properly. And doing it properly is not as hard as you think. Yeah, it takes time, and you're going to have to do some research. But ask yourself this: would you rather spend some time and do some research, or would you rather spend that extra money for that new next generation graphics card. Because I know I would rather spend some time and learn a few new things before I start to spend the amount of money that a new piece of hardware costs these days. So in my opinion, overclocking is worth it. We're not just doing it for shits and giggles, we're not just doing it for HWBot and our competitions there. It is actually something that everyone should be doing. Because the data says so, everything is here, you can look at all of it, and I stand more reinforced in my belief than before. I was not expecting the full overclock to approach 20% performance. I was expecting something between 7 and 10% on average, which for the easy overclock, yeah, that's about what happened. But the full overclock, it is just that much faster. You could not deny that that is a very significant increase in performance. And that is what I want to end the video on. Thank you all for watching. Getting all of this data, getting all of this organized, and getting all the math done was very intensive. I am not lying when I say I got out of bed on Sunday and I did all of this, and then I went to bed. I spent my entire day working on this, and, well, it was a lot of work. So, I think this had to be done. I wanted to answer this question because when you do stuff like me, you mod hardware, you overclock it, for a little bit of a friendly competition and just kind of seeing how far you can push it, that's one thing. But to see that this practice has actual utility in the real world, that's something else. It is worth to do. It is very worth to do. And I want to bring this out into the world so people see it and people start overclocking, because when people overclock, that can only lead to better products and better hardware for us down the line. Because when people overclock, manufacturers actually have to deliver something that's better and not just something that is maybe 10% faster, because we can beat that by overclocking. Anyway, I think this has been going on for long enough now. And until next time, goodbye.